So this is the last problem in section 10.3. We talked about what an identity matrix was, what an inverse matrix was, how to find an inverse matrix. So this is an example of where you could use an inverse matrix. Okay, and then later on in section 5, I'm going to show you another place that is actually cooler than this to use inverse matrices, because I don't really like this method when it comes to solving systems of equations, but it is a valid method. If you're able to find the inverse fairly quickly, it's not a bad method. There are times when it's good, there's times when it's rather tedious. The one I'm going to show you today, you're probably going to think is rather tedious, all right? But basically, what we are going to have is we're going to have what's called a matrix equation. So this matrix equation is made up of A, the coefficients, so all those numbers that are in front of the x's, the y's, and the z's. That'll be its own matrix. So if there's 3 equations, 3 variables, that matrix will be a 3 by 3. This capital X is representing the variable matrix. So if you only have 2 variables, it would just be x and y in there. If it's 3 variables, it'd be x, y, and z in there. Okay? And it's going to look weird how it's oriented because it has to be set up because this is matrix multiplication. So if this is a 3 by 3 for A, then x has to be a 3 by something. So it'll be a 3 by 1. Okay? And then B is your constant matrix. It's the values that your equations are equal to. All right, so just kind of jumping ahead, you already have the next example that I'm going to be doing. So I'm going to show you what that would look like. It would look like this. Here's A. Here's the 3 by 3 that's made up of all the coefficients that you see in the example that's in your notes. All right, and that'll come up here in a little bit. So those people watching this video are like, wait, where'd those come from? But you got to look at your note packet. These are the coefficients. These are my 3 variables, x, y, and z. Notice they're not written horizontally because this is a 3 by 3, and so this has to be a 3 by 1 because it has to be possible to multiply them together, right? If that second dimension is a 3, the first dimension of this one has to be a 3. If you multiply these, if you actually multiply these together, not going to do that, you would take this row times this column. So the 4 would be times the x, the negative 1 would be times the y, and the 1 would be times the z. So you'd end up with 4x minus 1y plus 1z. And then what would it equal? It would equal this, b. Those are the numbers that are on the right side of the equal sign. All right? So don't get too hung up on what I have here yet. Don't get freaked out. Let me explain why I have this extra stuff here. Okay? Because just like if I gave you a problem that said like 3x equals 27. It's a pretty simple equation to solve, right? To solve that equation, you'd probably tell me that you would divide by 3 on both sides, right? Well, technically, dividing by 3 is the same thing as multiplying by 1/3. Right? Now, the reason why we use 1/3 is that 3 and 1/3 are called multiplicative inverses. They're inverses of each other, right? Well, when I have this matrix equation, I am going to multiply both sides by the inverse of matrix A. So I'm undoing that matrix by using its inverse. Just like over here, I multiply by 1/3, I am multiplying by the inverse to get rid of it. Okay? And then what happens over here when you do that? What is 1/3 times 3? It is 1, right? So you get 1 times x equals 9. But you don't leave it as 1 times x, do you? You take 1 times x and you get that just to be x. Well, that has a special name too that we talked about the other day. That's called an identity. So what happens is, on this left side, when you multiply by the inverse of matrix A on both sides, these two things combine. Trying to click on it. These two things combine to be the identity matrix, which I have an I there. I didn't label that, but I stands for the identity matrix. So the inverses give me the identity, just like the inverses here give me the identity. Then the identity disappears because 1 times anything is just that anything. 1 times x is x. So the identity matrix times x is just x. So you'll be left with just the variable matrix on this side. Then you have to do a little work on this side. You'll have to multiply that inverse matrix times b, and you'll get 3 numbers for an answer, and that will tell you what x, y, and z are. Okay? So that's where we're going with this. So this is the basic process that is just like any equation solving problem you've ever done. Pretty much any problem you've ever done, you've gotten rid of something by doing its inverse. And that's what we're doing here. It's just that these inverses are a lot more complicated. Okay? So, this is the matrix that I showed you on the other screen. This is the system. It's not a matrix yet, but it's going to turn into a matrix. So, the first thing is that I'm taking the 4, the -1, the 1, the 2, the 2, the 3, the 5, the -2, and the 6. Those are all my coefficients, all 9 values. That is what is here in red. 4, -1, 1, 2, 2, 3, 5, -2, 6. Those are the same as these coefficients, right? The variables are x, y, and z. That's why that is my variable matrix. And then the constants on the other side, the -5, the 10, and the 1, those constants, that's my constant matrix. It is on the other side here, -5, 10, and 1. Now notice, right now, I have a 3 by 3 times a 3 by 1. If you take a 3 by 3 times a 3 by 1, you should get a 3 by 1 for an answer. And over here, what I have right now is a 3 by 1. So right now, this math problem makes sense when you think about matrices. A 3 by 3 times a 3 by 1 would indeed give me a 3 by 1 for an answer. Okay? So here's the hard part. I have to figure out what the inverse matrix is. Now, for this problem, I'm going to have to find the inverse matrix, and then I'm going to have to use it to solve this problem. As far as a test or quiz, I would not give you a problem like this one to do the whole thing. I would have a separate problem, have you find an inverse. And then have a problem like this where I would just give you the inverse and say, okay, I've already found it for you. Now use it to solve this matrix equation. Because if you were able to watch the other video I made the video first hour, I made a mistake finding the inverse. And I didn't have time to fix it before the hour was over. Okay, so hopefully I don't screw it up this time, but there's no guarantees, all right? I'm human, you're human. So it's possible that I'll mess it up. I hope not, because hopefully you guys will be paying attention and watch what I'm doing. So I'm going to show you how to find the inverse. And then we're going to use it to then put this together, because here's what happens. If you have matrix A times the inverse, once I figure that out, these two things will multiply together to be the identity matrix. That's what I had on that previous screen, right? And then the identity matrix times XYZ will give me just XYZ. So this side will simplify quite nicely down to XYZ. But I also will have to take that inverse on this side times the constant matrix. So I'll have to multiply these together. I've got it already set up for there to be a fraction out front. You'll see why I have that. I've saved that space. But this, when I multiply this is going to be a 3 by 3 that we're going to find. A 3 by 3 times a 3 by 1, I'm going to get a 3 by 1 for an answer. So I'm going to get 3 numbers here. I'm going to have a fraction outside. And then when I get my final answer, I'll have 3 values here. X will be the first value, Y will be the second value, and Z will be the third value. So fingers crossed. Let's hope this all works out. Okay? Okay, so here's matrix A. I need to find its inverse. So I did not mean to do that. All right, so here we go. So here I have, this is matrix A right here. This side, this left side here, this is matrix A. I have to change that to 1s and 0s. When I get done changing that to all the 1s and 0s to put it into reduced row echelon form, the matrix on the right, the stuff in blue, those numbers are going to change. And those numbers that are in blue, those locations will then be the inverse of A. Okay, so right now, this is A, and this is the identity matrix. So the first thing I'm going to do is I want to get a 1 up here on top. So what I decided to do earlier is I decided to take 4 times -1 and add it to the 5. If I take 4 times -1, that's -4 plus 5 would be a 1. But I'm going to replace the top values. Okay? So I know I wrote this kind of big, so I'm going to try to write a little smaller. But the bottom row, 5, -2, 6, 0, 0, 1, that's not going to change. The 2, 2, 3, 0, 1, 0, that's not going to change. But I'm going to take 4 times -1 and add it to 5, and I get a +1. I'm going to take -1 times -1, that's 1, added to -2 is a -1, I think. I hope. 1 times -1 is -1, plus 6 would be a 5. 1 times -1 plus 0 would be a -1. 0 times -1 plus 0 is still a 0. 0 times -1 plus 1 would be a 1. So, unless somebody objects, I think I did that correctly. So hopefully somebody is just double checking my math as I go to see if you see any mistakes. So now, I need to make this a 0, and I need to make this a 0. So the top row is not going to change. 1, -1, 5, -1, 0, 1. What I don't like about this is there's a lot of writing down of numbers over and over again. It's really easy to mess up, like forget a negative sign or make a calculation error or something like that. To make that 2 a 0, I'm going to take row 1 times -2, and I'm going to add it to row 2. So 1 times -2 plus 2 is 0. -1 times -2 is +2 plus 2 is 4. 5 times -2 is -10 plus 3 is a -7. -1 times -2 is 2 plus 0 is 2. 0 times -2 is 0 plus 1 is 1. And 1 times -2 plus 0 is a -2. And so hopefully I've done that step correctly. I'm also now going to take row 1 times -5 and add it to row 3 to replace those values. So, again, 1 times -5 plus 5 better give me a 0. That was what I was trying to do. -1 times -5 is a +5, plus the -2 would be a +3. Then I have 5 times -5, -25, plus 6 would be -19. So this is where with a calculator, I'd be going -1 times -5 plus 0. Okay, that comes out to be 5, I believe, right here. And I'd be taking this one, don't really need to do. 0 times -5 plus 0 is still going to be a 0. And then 1 times -5 is -5. -5 plus 1 is a -4, is that right? Okay. I think I just figured out where I screwed up earlier today. So anyway, it's right there. I think I got a 1 in that spot, and I'm like, something's not right. And it's throwing off everything after that. Okay, so now I need this. I swear I picked a different color. Let's try that again. Board does not like me. I need this to be a 1. So I'm going to take row 3 times -1. I'm going to add it to row 2. That'll use the bottom row to make that have a 1 there. So top row 1, -1, 5, -1, 0, 1. That stays. 0 bottom row, 0, 3, -19, 5, 0, -4. So as I do that, 0 times -1 plus 0 is still 0. 3 times -1 plus 4 is a 1. Better be, that's what I'm shooting for. -19 times -1 is a +19, plus -7 would be a +12. 5 times -1, -5 plus 2 would be a -3. 0 times -1 plus 1 would be a 1. And -4 times -1 is 4, plus a -2 would be a 2. Okay? Now, I need this to be a 0, so I'm just going to take row 2 plus row 1. So middle row is going to stay the same. 0, 1, 12, negative 3, 1, and 2. We all starting to see why this is not my favorite method? Very tedious. So 0 plus 1 is still 1. 1 plus negative 1 is 0. 12 plus 5 is 17. Negative 3 plus negative 1 is negative 4. 1 plus 0 is 1. 2 plus 1 is 3. That one was pretty easy. I need this to be a 0. So I'm going to take row 2 times negative 3 and add it to row 3. So when I take 0 times negative 3 plus 0, it's still 0. 1 times negative 3 plus 3 is 0. 12 times negative 3 is negative 36. Negative 36 plus a negative 19 is a negative 55. Feel good about that because I know 55 starts showing up in this problem. Negative 3 times negative 3 is a positive 9. Plus 5 would be 14. 1 times negative 3 is negative 3 plus 0 is a negative 3. And then 2 times negative 3 plus a negative 4 is a negative 10. Okay, are you with me? Now, the rule to get your last one, you have to do what? You got to divide by, I have to divide everything there. I'm going to take row 3, and I'm going to divide by negative 55. So, 1, 0, 17, negative 4, 1, 3, 0, 1, 12, negative 3, 1, 2. Here I get 0, 0, 1. Negative 14 over 55. Positive 3 over 55. And 10 over 55. Now, I'm leaving, I know I could reduce 10 over 55, but I'm not, I want them all to have the same denominator. Because I'm going, remember that back here where I said, it's not here, back here, where I said I'm going to have this fraction out here. If I have them all with a 55, instead of having a bunch of fractions in here, I'll just pull the 55 out here as my fraction outside. And then that'll make all of these integers in here, which makes life a lot simpler. All right, just gonna have to trust me on that for now. I'll prove it to you later, okay? Make sure I get to the right screen. There we go. So, I now have to get rid of that 12. I forgot that I even had this down here. Erase that so you can see my work. This is my work from earlier. Too far down. All right. So for now, the bottom is not going to change. 0, 0, 1, negative 14 over 55, 3 over 55, and 10 over 55. This is what this is going to end up looking like anyway, so I'm just going to write it down. But here's what I'm doing. So I need this 4 to be gone, right? I'm sorry, not the 4, the 17. I need the 17 to be gone. So I'm going to take row 3 times negative 17, and I'm going to add it to row 1. You're going to be like, oh my gosh. All right, but with a calculator, this is not so bad. Because I already know that that's going to make that 0. The question is, what does it do to this negative 4, this 1, and this 3? Okay, what does it do to it? So I'm going to start off, I'm starting off with this number. This number is my row 3 number, and the 4 is my row 1 number. So I'm just typing it in exactly like that. I'm going to type in negative 14 divided by 55, I put that in parentheses, times negative 17, and then I'm going to add a negative 4 to it. And it's going to give me this. Yep. Math, fraction. Comes out to be a huge number, so I feel like I screwed something up. Oh, it would help if I typed it incorrectly. So if I go math, fraction on my calculator, it comes out to be 18 over 55. Which, notice right here, see how I have this 18 here, and this 55 out here? That's not a coincidence, okay? Now, what I would do is I'm also going to be taking row 3 times negative 12 and adding it to row 2. So you could just change these two numbers in here. So as I go through and do this, let's see, so change that to a negative 12, change that to a negative 3, math, fraction, comes out to be, this one comes out to be 3 over 55, okay? So as I go through and do this, and now I take 3 over 55 times negative 17 plus 1. And I'm going to take 2 times negative 17, or I'm sorry, 10 over 55 times negative 17 and add it to 3, and so forth. As I do that, what I'm going to end up with here is 4 over 55, negative 5 over 55. Now my calculator is going to give me like negative 1 over 11. When I do this on my calculator, it's going to say negative 1 over 11, but I want it to have a denominator of 55. So all I do is multiply the top and the bottom by 5, okay? This one's going to give me 19 over 55. This one's going to give me like negative 2 over 5, negative 2 over 11. But I'm going to write it as negative 10 over 55 so that they all have that denominator of 55. So this is my inverse of A. But I'm going to write it this way. I'm going to pull out that 55. Okay? Everybody following how I'm getting all this? Okay. So now here's where finally the payoff is. So I go back to this other screen. And I'm going to have 55 goes here and here. The numbers on the inside were, let's see, what was it? I lost 18, 4, negative 5. So 18, 4, negative 5. 18, 4, negative 5. What's my next row? 3 what?
3, 19, and negative 10.
Okay. 3, 19, negative 10. And the last one was like 14, negative 14,
3, 10.
and 10. Okay. Now, technically, I mean, you could multiply all this out, but these are inverses. So when they multiply, they get you all these ones and zeros. And then when you take the identity matrix times XYZ, it becomes XYZ. All right? So then what you have to do is on this side, I have to multiply these together. This is a 3 by 3 times a 3 by 1, which is going to give me a 3 by 1. You're going to take this row of values times that column. So you take 18 times negative 5, 4 times 10, negative 5 times 1, and you add those up. And when you add those up, you're going to get negative 55. Then you do the second row times that column. So you take the 3 times the negative 5, 19 times 10, negative 10 times 1, and when you do that, you're going to get 165 for an answer. Okay? Again, this is just matrix multiplication. Then you take the last row times that column, and you add those up, and you will get 110. The last step is now you're going to distribute this 1 over 55, which basically means you're dividing by 55. So negative 55 divided by 55 comes out to be negative 1. 165 divided by 55 comes out to be a positive 3. And 110 divided by 55 comes out to be 2. So my final answer is negative 1, 3, 2.